Exothermic welds are generally not permitted on gas lines according to the National Fuel Gas Code NFPA 54-2006. Section 5.3 addresses other joints and specifically outlines what is and is not acceptable for joining gas piping. Section 5.3.1 states that brazed joints and copper tube shall not be made except in manufactured fittings specifically fabricated for brazing. Then Section 5.3.2 clearly states that exothermic welding shall not be used except for joining steel pipe. This indicates that exothermic welding is only permitted for joining steel pipe and is prohibited for other gas line materials. The reason for this restriction likely stems from safety concerns and the potential for compromising the integrity of the gas line. Exothermic welding involves creating a molten metal joint using the heat generated by a chemical reaction. While effective for certain applications, it may introduce weaknesses or inconsistencies in gas piping systems if not performed with precise control on appropriate materials. Firstly, brazed joints are allowed, but only with manufactured fittings designed for brazing. This ensures a controlled and reliable connection. Secondly, exothermic welding is restricted to steel pipe, recognizing its suitability for this material under specific conditions. It's crucial to always consult the latest edition of NFPA 54 and local codes for the most up-to-date regulations and requirements. These codes are regularly revised to reflect advancements in technology and address emerging safety concerns. Ignoring these regulations can have serious consequences, including gas leaks, explosions, and property damage. It's important to also remember that the authority having jurisdiction, or OJ, has the final say. Local codes and interpretations might differ from the national standard. Therefore, always consult with your local building department or gas inspector for clarification and guidance. Firstly, ensure all gas piping work complies with NFPA 54. Secondly, only use brazed joints with approved fittings for copper tubing. Thirdly, restrict exothermic welding to steel pipe only. Fourthly, consult local codes and the AHA for specific requirements. Fifthly, prioritize safety and proper installation techniques to prevent gas leaks and other hazards. For steel pipe, proper preparation is essential for a sound exothermic weld. This includes cleaning the pipe ends to remove any rust, scale, or other contaminants. The alignment of the pipes is also crucial to ensure a uniform weld. Use the correct mold size and type for the pipe diameter and joint configuration. Always follow the manufacturer's instructions for the specific exothermic welding system being used. The amount of welding powder, ignition method, and cooling time can vary depending on the manufacturer and the application. Proper ventilation is necessary to avoid inhaling fumes generated during the exothermic welding process. Wear appropriate personal protective equipment, including safety glasses, gloves, and a respirator. Allow the weld to cool completely before removing the mold. Visually inspect the weld for any defects, such as cracks, porosity, or incomplete fusion. If any defects are found, the weld should be repaired or redone. Non-destructive testing methods such as radiographic testing or ultrasonic testing may be used to verify the integrity of the weld. When working with copper tubing and brazed joints, use a suitable brazing alloy that is compatible with the copper material. Clean the copper tubing and fittings thoroughly before brazing. Apply a flux to prevent oxidation during the brazing process. Heat the joint evenly until the brazing alloy flows freely into the joint. Allow the joint to cool naturally. Avoid quenching the joint with water, as this can weaken the braze. Inspect the brazed joint for any leaks using a soap bubble test or other leak detection method. Gas piping systems should be designed and installed by qualified professionals who are familiar with the applicable codes and standards. Proper training and certification are essential for ensuring the safety and reliability of gas piping systems. Regular inspections and maintenance are important for identifying and addressing any potential problems before they become serious. If you suspect a gas leak, evacuate the area immediately and contact the gas company or fire department. Never attempt to repair a gas leak yourself. Remember, gas piping systems are critical infrastructure components that require careful attention to detail and adherence to strict safety standards. Understanding the regulations regarding exothermic welding and other joint types is essential for ensuring the safe and reliable operation of these systems. When in doubt, always consult with a qualified professional or the authority having jurisdiction. Always prioritize safety and never take shortcuts or compromise on quality. It is also important to understand the different types of steel pipe that may be used for gas piping systems. The type of steel pipe will affect the welding procedure and the type of welding rod or filler metal that is used. Some common types of steel pipe include carbon steel, stainless steel, and alloy steel. Carbon steel is the most common type of steel pipe used for gas piping systems. It is relatively inexpensive and has good strength and weldability. Stainless steel is more corrosion resistant than carbon steel, but it is also more expensive. Alloy steel has higher strength and toughness than carbon steel, but it is also more difficult to weld. The selection of the appropriate type of steel pipe depends on the specific application and the environmental conditions. For example, stainless steel is often used in corrosive environments, such as near the coast. Alloy steel is often used in high-pressure or high-temperature applications. In addition to the type of steel pipe, the wall thickness of the pipe is also an important consideration. The wall thickness of the pipe must be sufficient to withstand the pressure of the gas being transported. The wall thickness is typically specified by the applicable code or standard. For example, NFPA 54 specifies the minimum wall thickness for gas piping systems. The welding procedure must also be appropriate for the type of steel pipe and the wall thickness. The welding procedure should be qualified in accordance with the recognized standard, such as AWS 10.1 Structural Welding Code Steel. The welding procedure qualification ensures that the welding procedure will produce a sound weld that meets the required strength and toughness. The welder must also be qualified to perform the welding procedure. The welder qualification ensures that the welder has the necessary skills and knowledge to produce a sound weld. The welding rod or filler metal must also be appropriate for the type of steel pipe and the welding procedure. The welding rod or filler metal should be selected in accordance with the recognized standard, such as AWS 5.1 specification for carbon steel electrodes for shielded metal arc welding. The welding rod or filler metal should have a chemical composition and mechanical properties that are compatible with the base metal. It is also important to control the heat input during the welding process. Excessive heat input can cause distortion and cracking. The heat input can be controlled by adjusting the welding current, voltage, and travel speed. The welding process should be monitored to ensure that the heat input is within the specified range. After welding, the weld should be inspected to ensure that it is free of defects. The inspection should be performed in accordance with the recognized standard, such as AWS 10.1. The inspection should include visual inspection, radiographic inspection, and ultrasonic inspection. Any defects should be repaired in accordance with the recognized standard. It is critical to ensure that all gas piping systems are properly designed, installed, and maintained. Proper design includes selecting the appropriate materials, sizing the piping correctly, and providing adequate support. Proper installation includes following the manufacturer's instructions, making sound welds, and testing the system for leaks. Proper maintenance includes inspecting the system regularly, repairing any leaks promptly, and replacing any damaged components. By following these guidelines, you can help ensure the safety and reliability of gas piping systems. Remember that gas piping systems are critical infrastructure components and should be treated with the utmost care and respect. Always consult with a qualified professional if you have any questions or concerns. Furthermore, understanding the specific requirements for different types of joints in gas piping systems is crucial. While exothermic welding is generally restricted to steel pipes, other methods exist for joining different materials. Threaded joints are commonly used for steel pipes, but they require the use of a pipe sealant to ensure a gas-tight connection. The sealant must be compatible with the gas being transported and should be applied according to the manufacturer's instructions. Flanged joints are used for larger diameter pipes or when frequent disassembly is required. Flanged joints consist of two flanges that are bolted together with a gasket between them. The gasket must be compatible with the gas being transported and should be properly compressed to ensure a gas-tight seal. Compression fittings are used for connecting copper or plastic tubing. Compression fittings consist of a nut, a sleeve, and a body. The tubing is inserted into the body, and the nut is tightened to compress the sleeve against the tubing, creating a gas-tight seal. Flare fittings are also used for connecting copper tubing. Flare fittings consist of a nut, a sleeve, and a flared end on the tubing. The flared end of the tubing is inserted into the body, and the nut is tightened to compress the flare against the body, creating a gas-tight seal. Push-fit fittings are a relatively new type of fitting that is used for connecting copper or plastic tubing. Push-fit fittings consist of a body with internal teeth that grip the tubing when it is inserted. Push-fit fittings are quick and easy to install, but they are not as strong as other types of fittings. It is important to select the appropriate type of fitting for the specific application and to install it according to the manufacturer's instructions. Improperly installed fittings can leak, which can create a fire or explosion hazard. In addition to the type of fitting, the size of the fitting is also an important consideration. The size of the fitting must be compatible with the size of the tubing or pipe being connected. Using the wrong size fitting can damage the tubing or pipe and can create a leak. It is also important to use the correct tools when installing fittings. Using the wrong tools can damage the fitting and can create a leak. For example, when tightening compression fittings, use a torque wrench to ensure that the nut is tightened to the proper torque. Over-tightening the nut can damage the fitting and can create a leak. Under-tightening the nut can also create a leak. In summary, exothermic welding has very specific parameters around the type of material that it can be used on. Consult the most up-to-date regulations and always seek a professional. Do not rely solely on online resources.